right, algebra students, Mr. Foster here. We're going to go through the 7.3 notes. Hopefully, we'll get through without any mistakes. Let's see what happens. All right, when we look at this first of all, what we're doing is we're practicing multiplying two binomials. That's a polynomial with two terms times a polynomial with two terms. And then we're also going to be looking at factoring trinomials. So let's get into it. All right, in this first example, problems 1 and 2, we're going to try a couple of different ways of going about this. All right, so first it's asking us, let's multiply 12 times 7 using the method of distributive property. Meaning, let's look at if we know this is like the first part, and this red one is the second part. We're going to only take one term at a time from the front and multiply it times the part at the back. So it's kind of going to go like 7 times both of those, and then it's going to go 5 times both of those, and one at a time. So let's see how that works. So let's try 7. Let's put 7 in front. Helps if you actually pick a pen. 7 in front, and it's 3 plus 4 in here. And then the second one's going to be 5. We'll do that one in the color it should have been. 5, and we're going to multiply that times 3 plus 4. And so then when we go to do this work, it just kind of becomes a little simpler. So we're going to distribute, we'll do everything in kind of green rainbows. 7 times 3 is 21, plus 7 times 4 is 28, plus 5 times 3, which is 15, plus 5 times 4, which is 20. And then when we add all that together, we get 21 plus 28 is 49, plus 15 is 64, plus 20 is 84. And the good news is, if we know our times tables, we know that 12 times 7 equals 84. So that worked out okay. Now let's try using a different method. We call it a graphic method or a box method, whatever works for you. Now we take the parts and we split them apart. So remember, initially we had 7 plus 5 and 3 plus 4. So we just put those numbers outside this box and then we multiply in. So if we do 3 times 7, we get 21 right into that box. Basically, we multiply into each box. If we do 4 times 7, we get 28. And then if we do 3 times 5, we get 15. And if we do 4 times 5, we get 20. Really looks the same as it did above, but it's just graphical. The thing I like about this is it's harder to miss. It's almost impossible to miss multiplying one of the terms by one of the other terms. All right, let's look at that though if there's variables involved, because that can happen, right? This time we have x minus 2 times x plus 4. So same thing. We're going to write x in this first box, and we're going to write negative 2 in this second one. And then we're going to put x plus 4 in the other box for both. And then we just start doing the math. Let's distribute x times x, and we get x squared. Let's do x times 4, and we get 4x. And then we'll switch colors on us here. Then let's do negative 2 times 4, and you get negative 8. Oops, that should have been x. I did not write the right thing. Time to erase. That should have been an x in blue. Blink. Alright, so that would be negative 2x. And then that would be negative 8. And then we just need to combine the like terms, which is the middle group there. Like these two guys can come together. So we get x squared. 4x minus 2x is just 2x. and minus 8. Now let's look at that using the box method, the graphical method. All right, if we're using the graphic organizer, we put the term x minus 2 on top and x plus 4 on the side. Then we just multiply in. So let's do that. X times x, x squared. X times 4, 4x. X times negative 2 is negative 2x. And 4 times negative 2 is negative 8. And then this is the part when you use graphical with variables. You got to remember that then now we got to combine these gray diagonals. And we get the same result. We get x squared plus 4x minus 2x, which is plus 2x minus 8. All right, so let's practice trying that on our own. You do these next 3, and pause me first, do these next 3, and then see if we agree on the results. Okay, so if we do distribution method, I got x times x is x squared. X times negative 2 is negative 2x. Five times x is plus 5x. And 5 times negative 2 is negative 10. Close it all up. Just combine our like terms in the middle. And so our final answer would be x squared plus 3x, because 5x minus 2x is 3x, minus 10. All right, and I'll do it, I'll use the box method in the middle, but that's distributive method. Box method just is, again, draw a rectangle with 4 rectangles inside. Put each of your components above. So I'm going to go x minus 3 on top, x minus 4 over here. Then multiply in. X times x, x squared, negative 3x, negative 4x, and positive 12. Because we multiplied a negative times a negative. So then remember, we got to go with the diagonals. We got to combine these guys. So when we're combining it all, we started with x squared. Negative 4x and negative 3x makes negative 7x plus 12. And then if we go with the distributive method again, x times x is x squared. X times 6 is, or negative 6 is negative 6x. This one produces an interesting result because then 6 times x is plus 6x. And 6 times negative 6 is negative 36. Combine our like terms in the middle, and they go away because 6x minus 6x is just 0. And so we end up with x squared plus 0x, which I'm not going to write, minus 36. Okay. Pause there if you need to look that over. Otherwise, let's move on. All right. So what we did before is we took 2 binomials and multiplied them or squished them together to create a trinomial. Now what we're going to do is go the other direction. We're going to take a trinomial and we're going to break it into its binomial parts. So let's see how we do that. well, not how we do it. We're going to look at part of where that came from, though. So you may remember that x squared plus 3x minus 10 came from the factors were x plus 5 and x minus 2. X squared minus 7x plus 12 came from x minus 3 and x minus 4. And x squared minus 36 came from x plus 6 times x minus 6. All right? Those were the factored forms that led to these three trinomials. Now, let's see where, if we look at those trinomials, where did we get the first term? We'll do all of these in, I don't know, green. So the first term, x squared, where did that come from? Well, that just came from x times x. Or in this case, x times x. And likewise, x times x. Where did we get the second term, or the middle term? Three x came from these two. 5 times x plus negative 2 times x. In the middle here, we got negative 3x times x plus negative 4 times x. And in this last one, the middle term's really missing. It's 0. It's missing because it's 0. And that just came from 6x times, or 6x plus negative 6x, or 6 times x plus negative 6 times x. And then lastly, where did we get the constant? I don't know if I can keep these all on screen at the same time. I'll try. So pick a nice new color. We did green. Oh, go with like a powder blue. So where did negative 10 come from? That came from multiplying the constants. 5 times negative 2. Negative 3 times negative 4. And 6 times negative 6. So that's just a visual of where all those parts came from, how the broken apart factors give us the trinomials. All right, let's look ahead. Now we're going to practice factoring trinomials that have a lead coefficient of 1. All right, so we need to factor these. Now, we practiced this a little in the last lesson, so hopefully you'll remember this. We are using the Foster method to try and do this, which means we're finding what multiplies to negative 15 but adds to 2. So I have to think about factors of 15. Well, possibilities are, and it's negative 15, and one of them needs to be negative, one of them needs to be positive. That's the only way you can multiply to get a negative number. Well, and it needs to add to a positive, so the bigger number needs to be positive. So I'm going to write, one of the possibilities is negative 1 times 15, but that adds to 14. So that's no bueno. That just won't get the job done. All right. Another possibility is, well, there actually aren't very many possibilities here. The only other possibility is 3 and 5. So we're going to go negative 3 times positive 5 is equal to, actually when I added those up above, that was plus, times, but when I added them, that was, so when I multiply negative 3 times 5, I get 15, and then when I add them together, I get 2. And that's exactly what we were looking for in the middle there. All right. So when we go ahead and write those two binomials, we're going to write x minus 3 times x plus 5. And we'll prove it on this first one, but not on the rest. We'll prove that that's true. So I'm going to go x times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. And then when we combine those like terms in the middle, we get 2x. So that becomes x squared plus 3x, plus 2x minus 15. So that's just proving that these two binomials do multiply to get you to the original trinomial. All right, why don't you guys try B on your own? Find a way to multiply to positive 3, add to negative 4. The only way that's going to happen is if you have two negatives. Just a little hint. Pause for now and then come back once you've got this solved. Hopefully you're back from solving this. Let's see. I'm going to look for factors of 3. There are only 2. 1 times 3. And I said they both need to be negative. So hopefully you wrote x minus 1, x minus 3, because negative 1 times negative 3 gives us 3, and negative 1 plus negative 3 gives us negative 4. All right, go ahead and try C. C's a little bit tricky because it needs to add the 0 in the middle. So we're looking for numbers that multiply to negative 25 and add to 0. And the big clue here is it needs to be the same number, just one needs to be positive and one needs to be negative. Hopefully you realized that this is just x plus 5 times x minus 5. All right, last one. It's not labeled, but we're going to call this one problem D. What multiplies to 9 and adds to negative 6? Give it a go. Hopefully you came back with x plus 3. I'm sorry. Whoops. Excuse me. X minus 3 times x minus 3. And some of you may have found a faster way to write that because something times itself just means it's squared. So we could write this x minus 3 squared. And there we have it. All right, that is it for lesson 7.3. Hopefully that was helpful. If you have any questions left in your head, you probably do, bring those up with your teacher. Thanks for listening. Take care.